So good morning, students. So let's start our discussion on the ellipse unit test. So let me, provide the first question, and it will be available to you in another few seconds. So I hope all of you are able to view this question, right?
Yes, sir.
Yes. So what I would like to know from you is that, what is the solution you got, Pratik? Find the locus of the middle point of PQ. Okay. So what is that? What is that curve? That locus. The question here is that a variable normal of an ellipse x square by s square plus y square by b square equal to 1 cuts the circle x square plus y square equal to a square at points P and Q. Find the locus of the middle point of PQ. Now, we can draw a diagram for this representing this problem, but that is also not required. But before I start, providing the solution, anyone has any answer? Shrestha, Tejas, Pratik? If you do not have any answer, then I can provide the solution and I'll discuss. If you have solution also, then also you can discuss.
Sir, is it x square by a square plus 4y square by b plus a whole square is equal to 1?
No, not really. No, it is not correct. Okay. So,
So is it y is equal to 0?
no, not at all. How come? Absolutely not. Okay. Y equal to 0 means what? It is x-axis. Do you think it is x-axis if you represent that one? A variable normal. Think about that variable normal. Okay. And that normal is cutting that, circle x square plus y square at points P and Q. It can't be. Now, how to proceed? I want to, provide you the solution and we will discuss without drawing the diagram of this one. Just by using analytical methods, we can do this thing. Now, before that, you need to know one thing, that the equation of the normal at an arbitrary point, what is an arbitrary point on that ellipse? It is a cos theta comma b sin theta, correct or not? So, the equation of the normal at an arbitrary point a cos theta comma b sin theta on the ellipse x square by a square plus y square by a square equal to 1, that has a equation which actually comes with the formula. So which I discussed in the formula. So here it is. So let's first understand one by one. Dear Tejas, did you solve this one, by the way?
Yes, sir.
Okay, what is the equation? What is the solution you got? What is the locus? Anyway, I am discussing the solution. If you get it, you can let me know. Or if it is not matching, then you can let me know where it is not matching and we can discuss. So if you look into it, dear students, that we see that the equation of the normal at an arbitrary point a cos theta comma b sin theta on the ellipse x square by a square plus y square by b square is equal to 1 is a cos theta into x minus b cosec theta into y is equal to a square minus b square. Now, this is a variable normal. Why? Because you vary theta, you get different point on the ellipse and you will get different normals to that ellipse at that point. So this is the descriptive question 1. Correct or not, dear students? So then, the above normal 1, that equation 1, what I gave, that a sec theta x minus b cosec theta y equal to a square minus b square. This normal cuts the circle x square plus y square equal to a square at the point P and Q. By the way, this is a circle which is the auxiliary circle to the ellipse x square by a square plus y square by b square equal to 1. Also, let the coordinate of the middle point of the line segment PQ be alpha comma beta. So according to the equation, according to the question, we need to find the locus of the point alpha comma beta. If any one of you have any any point is didn't understand, never hesitate to ask me, because I am proceeding further without asking any further question to you. So now the equation of the chord of the circle x square plus y square, whose middle point is alpha comma beta, there is the equation. Okay. So then what we can do is that, so let me pull the solution here, then followed by its explanation. So if you see here, the equation of the chord of the circle x square plus y square equal to a square, whose middle point is alpha comma beta, is what? Alpha into x by a square plus beta into y by a square minus 1, equal to alpha square by a square plus beta square by a square minus 1. Or in simple term, what we can write is that this comes with a formula which is available in my point notes. Alpha x plus beta y is equal to alpha square plus beta square. Now this equation 2 is the equation of the chord PQ, and it is also the normal as described in the equation 1. Correct, no, dear students? Okay. So what we see, that equation 2, I repeat, is the equation of the chord PQ, and also that is and PQ, and it is also the normal as described in the equation 1. So what you need to do? So the above equation 1, if you look into it, that above equation 1 is doing what? The above equation 1 and equation 2 are same. Correct or not? If you look into it, what is equation 1 is the equation of the normal. It is in the normal, equation of the normal of the ellipse. So that we use the formula of ellipse, equation of the normal to an ellipse. And at the same time, the same straight line PQ, okay, which is also chord to the circle x square plus y square equal to a square, which is the auxiliary cycle, by the way, is actually also formed that is in the equation 2. So if you see, equation 1 and equation 2 are actually same, but expressed in different forms. The first form in terms of normal to an ellipse, and the second form is the chord of a circle in terms of the midpoint of the chord. So now, as both the equations are same, then what we can do? We can perform simplification, and here is it. So let me share the solution with you, then we will discuss. As you see, dear students, that as equation 1 and 2 are same, so we can write that a sec theta by alpha minus is equal to minus b cosec theta by beta is equal to a square minus b square by alpha square plus beta square. Correct? And then we proceed further. We found the value of cos theta and sin theta from that given relation. And we know that sin square theta plus cos square theta equal to 1. So from this one, we find the value of cos theta and sin theta. Because when you form a locus, always remember, dear students, you need to express this locus in terms of the two variables, x and y. And what about the information given to you? Information given to us is a and b. Anyone has any simplest doubt before we proceed to the next question? All right. Let me proceed to the next question, dear students. The second question is in front of you. I'm interested to know what is your solution, dear students, here. What is the equation of the concerned ellipse? Rest, did you get it?
Sir, x square by 9 plus y minus 3 whole square by 5 is equal to 1.
Yes, sir, I got the same.
That is exactly the correct answer. Very well done.
Yes, sir. Even I got the
Okay. Now, let me share the solution what I developed and suggest you to have a quick look into it. And do let me know in case you found that your solution is, different from the one what I have done. Things are self-explanatory. If something is not clear, you can ask me or I can proceed to the next question better. Okay. Let me proceed to the next question, dear students. So what is the equation of the ellipse you got in this question?
X minus 1 whole square divided by 45 plus y minus 2 whole square divided by 20 is equal to 1.
Correct, you are. That is the
Yes,
correct.
sir, I got the same.
Yes, sir.
Okay, you got the same. Great. So good. Let me share the solution so that.
So was it correct? I didn't hear.
Yeah, I understood what you said, dear Shrest. I hear your voice very clearly. So what I'm saying is that let me share the solution as well. Is the solution visible to you, dear students?
So you
Or
can zoom it a bit.
So it's very small, sir.
very small? Okay. Let me correct it. So it is. I can correct it very easily. I hope now you can view it, dear students. Correct or not? Hello?
Yes, sir.
Any question you have, and if you find that your solution is different than the way I have done it, we can discuss. Okay, let me proceed to the next question, dear students. This is the descriptive question 4. Find the locus of the midpoint of the intercept of the tangent to the ellipse x square by a square plus y square by b square equal to 1 intercepted between the coordinate axes.
By x square plus b square by y square equal to 4.
Fantastic. Correct you are. Appreciate your answer. Very well done.
Sir, I couldn't get the answer.
Okay, sure. Definitely. I'll explain you. So the point is that, let me first pull the solution and then let me explain. I hope the solution is clear to you. It is visible, right? Correct, my dear students? Tejas, could you please confirm that the solution is visible to
Yes,
you?
sir.
Yes, sir. Yes, sir.
So, Shrest, you also didn't get that solution?
Sir.
So, let's discuss. Okay. We know that the equation of the tangent at any parametric point a cos theta comma b sin theta on the given ellipse x square by a square plus y square by b square equal to 1 is what? X cos theta by a plus x sin y sin theta by b is equal to 1. Sorry, it has to be y. My mistake. So that means x by a sec theta plus y by b cosec theta equal to 1. So why I wrote like this? Because I made it into the intercept form. Now, and I gave that equation as equation number 1. Now, if you look into that from the above equation 1, we see that the tangent meets the x-axis at the point p a sec theta comma 0 and y-axis at 0 comma b cosec theta. Let p alpha comma beta be the midpoint of the line segment pq. That means what? Alpha should be equal to a sec theta plus 0 by 2, that is a sec theta by 2, and beta equal to 0 plus b cosec theta by 2, that is b cosec theta by 2. According to the given question, we need to find the locus of the point alpha comma beta. So, as I said, alpha and beta, we found it out. Alpha and beta. And hence, see, this is a technique. Okay. Whenever you have parametric form is in the form of, in case of ellipse, if you see that a cos theta b sin theta, then what we need to do is that we find the value of cos theta and sin theta, and then we apply the formula cos square theta plus sin square theta equal to 1, and eventually we get a square by alpha square plus b square by beta square equal to 4. But what is our concern? Our concern is to find the locus of the point alpha beta. So definitely we should replace alpha by x and beta by y. And eventually we get a square by x square plus b square by y square equal to 4. Tejas, is it clear?
Yes, sir. Can you just give me a minute to just read through this?
Absolutely. Pratik, sorry, Shrest, is it clear? Pratik, you did well, I know.
Yes, sir. I understand. Yes, sir.
Okay, then you should think that why it has not, you didn't do in the first time. Because, all you have is that you must be knowing that what is the generic equation of a tangent at any parametric point a cos theta comma b sin theta on the given ellipse x square by a square plus y square by b square equal to 1. If you do not know, then you need to go to the relevant theory.
I understood it, sir.
Okay. Now let me come to the next one. The next question, dear students. The question number 5. So descriptive question number 5. There are exactly 2 points on the ellipse x square by a square plus y square by b square equal to 1 whose distance from its center is same and is equal to square root of a square plus 2b square by 2. We need to find the eccentricity of the ellipse. If someone of you already found it out, I am interested to know what is the value of it.
Sir, 1 by root.
Fantastic.
Yes, sir. One minute.
ओके ठीक है
Okay, great. It is 1 by root 2 indeed. Okay. Okay, so let me share the solution with you. I hope you are able to view the solution, dear students. Please go through it. If you are not able to get it, and then do let me know if you have any smallest query. Okay. If things are fine, then let me proceed to the next one, that objective questions. I hope the question is visible to you, dear students. What is the option you got?
Sir, C.
C.
See,
If all of you got C, then I think I don't need to explain. Okay, great. Appreciate. It is indeed C. Let me bring the next questions. Yes, please do let me know for question number 2.
Sir, D.
C.
You got
Sir,
D?
C.
Yes, it is indeed C. Correct, you are Pratik. Shrest, what you got? D?
Yes, sir.
Okay. So I can explain you this one. And okay, let me do one thing. Let me explain this solution, first. Let me bring this one by one, so that let me keep it in a, new, just a minute. Because it is very important to understand this question very well. So we should spend some time here to understand the solution. That is MCQ number 2. Okay. Dear Tejas, did you find that solution or not?
No, I didn't get any of the options, sir.
Okay. So if you look into it, so we find that we can describe this thing by means in this in the form of this a pictorial diagram. First, dear Tejas and Shreyas, please do let me know if you are not able to view this solution very clearly. If it is not, then I can increase the font.
No, we can see, sir.
Okay, so there are two ellipses. Okay, the locus of the point of intersection of the tangents at the extremities of the chords of the ellipse x square plus 2y square equal to 6, which touches the ellipse x square plus 4y square equal to 4. So that actually the adjoining diagram describes this. Correct or not?
Yes, sir.
Yes, sir.
Okay. Then how we can proceed? The way we can proceed is something like this. So then, according to the given condition, what we need to find? According to the given condition, we need to find the locus of the point alpha comma beta, isn't it? Now, the equation of the chord AB of the ellipse is what? Alpha into x by 6 plus beta into y by 6, beta into y by 3, that is equal to 1. that is coming from the formula. Let the coordinate of the point C be 2 cos theta, comma sin theta. Why? Because we took the parametric form. A cos theta, B sin theta. In case of the second ellipse, A is 2 and B is 1. X square by 4 plus y square by 1 equal to 1. That means A is equal to 2. 2 square is 4. So we took the parametric one. Or the advantages of taking the parametric one is that you reduce the number of unknowns. You could have taken that, let the coordinate of the point C be x1, y1. Then there are two unknowns, x1 and y1. But the moment you take the same point in terms of parametric form, it becomes 2 cos theta, 1 sin theta. That is sin theta. Now here the number of unknowns is 1. So our target should be as much as possible to reduce the number of unknowns, as it will help us to find the solution quickly. Now the equation of the tangent to the given ellipse 2 is, we know x cos theta by 2 plus y sin theta by 1 equal to 1. That is cos theta by 2 into x plus sin theta into y is equal to 1. Now what we can conclude? If you see, equation 3 and 4 are same, isn't it, dear students? So as the two equations are same, eventually we can perform this kind of simplification and algebraic operations. Please have a look into it and you'll understand why I have done so. And again, we found the value of cos theta and sin theta, like the previous questions, few of the previous questions, and apply the concept of cos square theta plus sin square theta equal to 1. And eventually we get alpha square plus beta square equal to 9. Now, as we need to find the locus of the point alpha comma beta, so we should replace alpha by x and beta by y. Hence, we get the correct option as C. Dear Shrestha and Tejas, did you understand why it is not D and C?
Sir, I didn't understand how did we get a point C?
How I get the point C? Okay, now tell me. Okay, good question. Appreciate your question. Means your question, if I understand that, how I get that coordinate of the point C as this, correct?
Yes,
This is
sir.
your question? Huh. So I think I explained, but let me explain once more. Think about x square by a square plus y square by b square equal to 1. This is an ellipse, na? Now, if I tell, on top of this ellipse, I need to select a point. Suppose this is the ellipse. Now, on that ellipse, we need to take a point. Suppose I take the point P. How
Oh,
we
yes, sir. Yes, sir. You took the 2 cos theta and sin theta so that it becomes.
Exactly. I could have taken x1, y1, but it will actually take longer time to solve that question. Got my point? But the moment
Yes, sir.
I
Yes,
put
sir.
yeah, that's what I explained, I think, a few minutes back. Anyway, you got it, right?
Yes, sir.
So, what is the lessons learned? Whenever you get any of this, conic section related problem, and you need to choose a arbitrary point on that one, be it parabola or ellipse or hyperbola, always take a parametric point. In a single statement, I can say, choosing parametric point is better than choosing an arbitrary point, because the number of unknowns in a parametric point is reduced. Okay, now let me come to the next question. That is question number 3. Okay, you
Sir,
can
is
let
it
me know.
Sir, A.
Very good. If all of you got A, fantastic. All of you got A, dear students?
Yes, sir.
Great. Appreciate. That was a good question, actually. All of you got A. Appreciate. Then let me go to the next question. Yeah, next question, dear students. Question number 4.
Sir, is it D?
Correct you are. It is D indeed. All of you got it, or shall I explain? Shrestha and Tejas, did you get option D for question number 4?
Yes, sir.
Shrestha, you got it?
Yes, sir.
Okay. Fine then. Then I'm not explaining, as all of you got it. So we should proceed. For question number 5, what you got, dear students? Pratik?
C.
Correct?
Sir, I couldn't get the answer for this.
Okay, definitely I'll explain you. But Pratik, your answer is absolutely correct. It is C. Dear Shrestha, did you also get C or something different?
Or different.
Different. Okay. Let's find it out. Here also the same concept we need to apply by choosing a parametric point. What is the question here? The tangent at the point a cos theta comma b sin theta on the ellipse x square by a square plus y square by b square equal to 1 meets the auxiliary circle in 2 points. The chord joining them subtends a right angle at the center. The eccentricity of the ellipse is what is the question. Now, first and foremost, dear student, is that first you need to get the equation of the tangent to the ellipse x square by a square plus y square by b square equal to 1 at the point a cos theta comma b sin theta. What is that? From the formula we know that one is cos theta by a into x plus sin theta by b into y is equal to 1. Correct? Now, after that we'll do some simplification. Let me share the solution with you and we'll discuss followed by it. So what we did first, we found the equation of the tangent to the ellipse, that is, which is there in the equation 1. Now, the equation of the lines joining the point of intersection of that above line 1 and the auxiliary circle. What is the auxiliary circle of the given ellipse? X square by a square plus y square by b square equal to 1. It is x square plus y square equal to a square. Okay. Okay, the line joining the point of intersection, we can get this one, x square plus y square is equal to, equation of the line joining the points of intersection of the above line 1. Okay, and the auxiliary circle of the given ellipse. So you will write x square plus y square equal to a square into 1. Instead of 1, we should take it that value of 1 as cos theta by a into x plus sin theta by b into y from the equation number 1. And that is one of the most important point here to proceed solution for further. After that, what we are doing, dear students, is that if you look into it, according to the given question, the pair of straight lines as represented by this equation number 2, as you see in the equation number 2, are perpendicular to each other. So if you now go back to the theory of the pair of straight lines, and what is the condition that the two straight lines will be perpendicular to each other? So we get this condition, that coefficient of x square plus coefficient of y square is equal to should be equal to 0. That is the condition. That is the precondition, by the way. Okay, so let me pull the solution properly. So now coefficient of x square plus coefficient of y square of the pair of straight line as represented by the is in equation number 2. That is equal to 1. That means cos square theta by a square, coefficient of x square that we know, 1 minus a square by into cos square theta by a square plus 1 minus a square into sin square theta by b square is equal to 0. And from there we found the value of that E as equal to plus minus. But you know that 1 plus sin square theta cannot be less than 0. And eccentricity always has to be positive, right? As you know. So definitely the value of E has to be 1 by square root of 1 plus sin square theta. Obviously, eccentricity cannot be negative, no, dear students. Anyone has any smallest difficulty to understand this? Please do let me know.
No, sir.
Okay, so now let me proceed to the next question, dear students. Okay, let me go to the next page for the next question.
Sir, B.
I'm sorry.
B.
Yes,
Sir,
B
B.
is the correct answer. Appreciate.
B,
All of
sir.
you got B. Tejas, you also got B.
Yes, sir. Yes, sir.
Okay. B. Let me proceed to the next question.
Sir,
Yes,
is
please.
it C?
Correct, you are. It is indeed C.
Sir, C.
Tejas, you
C,
got
sir.
C.
C, sir.
Correct, you are. It is C indeed. Let me proceed to the next question. Yes, dear students, for question number 8. Pratik, what you got for question number 8?
Sir, A.
Sir,
Yes, A is the
A.
correct answer. Tejas, you got A?
Yes, sir. Yes, sir.
Okay, all right. Let me go to the next question. That is question number 9. Yes, dear students, what is the option you got for question number 9?
C.
All of you got C?
yes, sir. I also.
Based on Tejas, did you get C? C is the correct answer, by the way.
No, sir.
You didn't
No,
get?
I didn't get C, sir.
So you didn't get option C. I
Yes,
need
sir.
to
Yes,
explain,
sir.
right?
Yes, sir. I got C.
Okay, I
Yes,
didn't
sir. Yes, sir.
understand about Tejas. Tejas, you got C? Okay.
No,
Let me
no, no.
explain
I
this.
didn't get C, sir. I didn't get C.
So what is the question here? An ellipse passes through the point 4, -1 and its axes are along the coordinate axis. If the line x plus 4y equal to 10 is a tangent to the ellipse, then the equation of this ellipse is what we need to find, right? So now, how to approach this question? As we do not know what is the equation of the ellipse B, let's assume the equation of the ellipse B x square by a square plus y square by b square equal to 1. Now, as that ellipse passing to the point 4, -1, we can replace the value of x as 4 and y as -1, and we will get a relationship between A and B. That is the first step. Okay, so let me share the solution and then we'll discuss. Okay. So, dear Tejas, as I was telling that, first you need to find that relationship between A and B as the ellipse passing to the point 4, -1, and we get it in the equation number 1, correct? No, this one. Now the line, let the line
Yes,
x
sir.
plus 4y equal to 10 be the tangent to the given ellipse at the point x1, y1 to the ellipse. Now the equation of the tangent at the point x1, y1 to the ellipse, we know this is the standard formula of the given equation of the ellipse, not in parametric form, but in the normal, that Cartesian coordinate x1, y1 form. Now, the equation of in the above equation 2 and the line x plus 4y equal to 10 are same, na? So we can always write that their coefficient are equal to the proportion of their coefficient of x and y is in equal proportion with the constant term. And we find the value of x1 and y1. Clear, na, dear students? Especially Tejas? Correct? The moment we find the value of
Yes, sir.
sorry, the moment we find the value of x1 and y1, that x1 and y1 is what? Is nothing but a square by 10, comma 4b square by 10. lies on the line x plus 4y equal to 10. So definitely we can replace the value of x1 as a square by 10 and y, y1 as 4b square by 10, and we write this thing. Okay, x plus 4y, 4 into 4b square by 10 means 16b square by 10 equal to 10. So we get another relationship between a and b, that is a square plus 16b square is equal to 100. So then what we get is that, if you look into the, the equations, that equation 1 and equation 3. From equation 1, we get a square plus 16b square is equal to a square b square. This one. Correct, no? And from the equation 3, we get a square plus 16b square equal to 100. Sure. What we can write is that a square b square is equal to a square plus 16b square is 100, which is from equation number 3. So a square b square is equal to 100. Now the moment a square b square equal to 100, so we can write b square, a square is what? 100 minus 16b square. From there we can find the value of b square, okay, is as 5 or 5 by 4. Correct, no, dear students? They just got it right.
Yes, sir.
After that, what we are going to do is that, by means of the relation a square into b square equal to 100, corresponding to b square equal to 5, we get a square equal to what? 20. The moment we get a square equal to 20, and corresponding to b square equal to 5 by 4, we get a square equal to 80. So what we get the pair of values of a square b square as either 20, 5 or 80, 5 by 4. So what we get? We get two possible equation or ellipses. First one is x square by 20 plus y square by 5 equal to 1. And second one is x square by 80 plus 4y square by 5 equal to 1. Correct? Huh? Got it? Hence we get the equation C as the correct one. Correct or not? Because 1 is matching, right? X square by 20 plus y square by 5 equal to 1.
Yes, sir.
Correct, no? Okay. Now let us proceed to the next question. Let me come to the next page for the next question. Now I'm going to discuss on question number 10. Let me first pull the question. Please do let me know your solution, dear students, for question number 10.
Sir, is it A?
Correct, you are. It is indeed A. All of you got A, dear students?
Yes, sir.
So I didn't get.
You didn't get? Okay, let me help you to understand. Okay, again, it is quite simple. If you look into in the parametric form, they are stressed. So let me share the solution with you. Then you realize that yes, what sir was telling is correct. So if you look into the question, if b into square root of 3x plus ay is equal to 2ab touches the ellipse x square by a square plus y square by b square equal to 1, then the eccentric angle of the point of the contact is what? That means if we take that arbitrary point on the ellipse x square by a square plus y square by b square equal to 1, then the arbitrary point is a cos theta comma b sin theta. Okay, and we need to find, according to the question, the value of theta. Correct, no? According to the question, we need to find the value of theta. Got it, right? So
Yes,
now,
sir.
then what we are going to proceed here, if you see, is that first we know that equation of the tangent as it is given in the equation 1, we have discussed several times today. Now that equation 1, be the line b into
Sir,
root
I
3.
understood.
You understood, right?
Yes, sir.
Because these two equations are same actually. Okay, now let me proceed to the next question, dear students. Question number 11. I'm going to show in front of you. Yes, dear students, for question number 11, what is your solution?
Sir, is it A?
Not really, it is not A. I
Sir,
hope
B.
B.
correct you are, it is B. Dear Pratik, let me explain why it is B. Okay, please have a look into the, it is self-explanatory by the way, because the way we have discussed several questions, it is a generic equation, right? So from that generic equation, we actually, transform that generic equation in the equation of a parabola.
Sir, I got it. I got it.
It's correct, no? Clear, no?
Yes, sir.
Okay, all right. It is quite straightforward. So let me go to the next question. That is question number 12.
Sir, D.
All of you got D? D is the correct answer indeed.
Yes, sir.
Yes, sir.
Tejas, you got D?
Yes, sir. None of these.
Okay, good. Let me go to the next question. That is question number 13.
Sir,
Yes.
B.
I'm sorry. It is D or B.
B, B.
B. B.
B,
Okay,
sir.
B. Correct you are. It is B indeed. Question number 13. It is indeed B. Thank you very much. Now let me come to the next question. That is question number 14.
Sir, D.
All of you got D, dear students. It is indeed correct. D is correct.
Yes, sir.
Yes, sir.
Tejas, you got it?
Yes, sir.
Okay. The last question for today, that is question 15. So I'm going to, let me first pull the question.
Sir, B.
Sir, B.
Yeah. So, from my previous experience, this particular question, none of the students make mistakes because this question is coming from that, ellipse chapter. Hence, all decided it is B. But let me share the solution. It is indeed B, but in case someone is having any simplest doubt, let me share that one, and that's it. So let me share this one. Okay, dear students, so I would like to conclude the class here. And in our next class, we'll be taking one unit test on work, energy, and power. Okay, please revise that. The question paper will be available to both the app and in the online test platform by tomorrow evening, 6 o'clock. It will be available in the KonarClasses.com online platform as well as KonarClasses Lite app as available in the Google Play Store. So, and we will be discussing day after tomorrow at 8:30 p.m. during our class. Okay. With this, I would like to conclude the class for today. If you have any specific question, feel free to me. All right. Thank you very much.
Thank you, sir.
Yes,
Thank
sir.